Now in this video we're going to give a brief introduction into quadratic functions, and these are going to look very familiar to the absolute value functions we have graphed in the past. So first thing we're going to do is look at the parent function for quadratics, and the parent function for a quadratic is x squared. So I went to the y equals button and x squared, and we're just going to look at this on the standard window. So I'm going to zoom 6 on the standard window, and that's what the graph looks like. Now you'll notice that it looks similar to the absolute value function, except it has a curved shape as opposed to the branches being straight lines. So that is what the parent function looks like. And what we're mainly going to do today is we're going to apply translations to this, just like we did with the absolute value functions. For example, and you're going to see that this is very similar to what we did for the absolute value functions. First two examples we're going to look at are pretty much just straightforward, either a vertical translation or a horizontal translation. And then the last two examples we're going to look at, we are actually going to look at doing both to those. And we're going to talk about how to find the x-intercepts and the y-intercept and so on. So to just review, if we look at, for example, vertical translation, if we move this down 5 units, for example, where we have x squared, and moving it 5 units down, we would have minus 5. So then if we look at the graph again, now that will be graphed in red. Notice how it's pretty much just moved 5 units straight down. Okay, and if we want to look at horizontal translations, and just to prove a point, and in this case, we're going to put something inside parentheses with the x. For example, what if we have x minus 5 inside parentheses? Now, just like with the absolute value, not 55, 5. There. Just like with the absolute values, this is a little bit similar to that, where if we have minus 5 inside, we should expect that to move 5 units to the right. So when we do hit graph, we will find that that is translated 5 units to the right. So the same rules apply to these quadratics, and the shape of this that we call this a parabola, and the shape is curved, but the same rules apply as far as the translation. So when we go to our notes, there's the parent function. Vertex is at the point 0, 0, and it's more of a curved shape than a V. We call it a parabola. And a lot of the same rules that applied to absolute value functions apply to these as well. So we're going to graph this first one, x squared minus 25. And since that minus 25 is not inside parentheses with the x, that's going to be a vertical translation, and we're going to move it 25 units down. So the vertex of this graph is going to be the point 0, negative 25. So we could graph this. If you look at D, we're asked to graph this. So here's a graph, and we're going to plot that point first. We're going to plot that point, and that is the point 0, negative 25, which also happens to be the y-intercept for this one. Okay? And again, like we talked about with the absolute value function and the line functions, and it's going to be a recurring theme this year, whenever you want to find the y-intercept of any graph, plug in 0 for x. So 0 squared is 0, minus 25 is negative 25. So that makes it the y-intercept as well. Okay, just plugging in 0 for x. Now to find the x-intercepts, it's a little bit more involved. Instead, we substitute 0 in for y. So to set this up, we're going to set this equal to y, and we're going to solve it for x. Now, the first thing you want to do in solving this for x is get the x squared part by itself. So we're going to we're going to add 25 to both sides. And to undo squaring, we're going to take the square root of both sides. And the square root of 25, what do you square to get 25 is 5. Now, here's the thing about this, though. There are actually two values we could put in for x and make that equation there true. Positive 5 is one of them. But if we also put negative 5 in for x, negative 5 times negative 5 is also 25. So therefore, we have two x-intercepts, positive 5 and negative 5. So this one, we are at 5, 0. And over here, we are at negative 5, 0. And it's going to be more of a curve, and it's going to look like that. Not a V, but a parabola. It's going to be a curve. And then to give the domain and range with any graph, don't forget to give the domain and range. So the domain of this graph, again, left to right, is going to be negative infinity to infinity. And the range goes from bottom to top. The y-coordinate at the bottom is negative 25 to the top, infinity. And that is the domain and range. Now, looking at a horizontal translation, where we have x minus 4 inside parentheses. And again, that's going to take that vertex of 0, 0 and move it 4 units to the right. Remember, with the horizontal translation, if it's inside with the x, it's a little opposite of what we would normally think. So the vertex of this graph is actually at 4, 0. So to put this down in a graph, the point 4, 0 would be about right there. So, and then to find the y-intercept, we basically want to plug 0 in for x. So 0 minus 4 is negative 4. Negative 4 squared is 16. So we will be up here at 0, 16. So this would be one branch of this. And parabolas, just like the absolute value functions, have symmetry. So that would be the other side of the graph. Now, the x-intercepts, again, the x-intercepts can be found by setting that right side equal to 0. And since we have the squared part by itself already, we're going to undo that by taking the square root of both sides. And in this case, 0 only has one square root. It's 0. Positive 0 is the same as negative 0. So to get the x by itself, we add 4. So that gives us our only x-intercept of 4. So then the domain and range, domain, again, left to right, is negative infinity to infinity. And the range, bottom to top, the y-coordinate at the bottom is 0. Top goes all the way to infinity. So that's a look at horizontal and vertical translations individually. In the next video, we're going to look at what happens when we combine the two into one.